To start with, we have a little review of regression. So if I gave you two numbers, 2 and pausing a second. All right. So let's say we had 2, 3, and 4, and 70.6, 74.8, and 79.1. The question is, what, if I'm going to call this x and this y, if I gave you an x of 14, what would you get? All right, use linear regression. Type that info in using stat. And once you hit stat, the first thing you do is edit. And you're going to edit list 1. Enter all the x data on list 1. Put in all the y data on list 2.
Is that a 79?
It is a 70.6 and a 74.8 and a 79.1. Then you're going to do second calculate lin reg. You're going to have to enter L1 and L2 in their appropriate spots. If you have the old style calculators, you say L1 comma L2, comma's right above the 7 key. And then you're trying to figure out, if I gave you x is 14, what would that yield? And you can do this with the table, but if you do it with the table, you're going to have to enter it onto the y1 equation. Like you'd have to go put the equation you have found onto y1 somehow. I did teach you how to do that, where you could type in under the vars key is where you'd find y1. Okay. By now I'm pretty confident that somebody has got this equation. Did you find the equation yet, sir? Maybe you got the answer, but what's the equation? Y equals
4.25x plus 62.1.
0.1. Would that round to that?
Yeah.
Okay, good. Thank you very much. There we go. And they usually give you these two separate things. A is this and B is that. And then you put it together into this one equation. Now, you can do it the old-fashioned way, which is to just go put a 14 right there and do it with yourself and a pencil and some paper and a calculator usually to multiply it out. Option B, you could do it the fancy way, where you could have typed this equation into the y equals screen, and then you could have done it on the graph or the table. Lots of options. What did you get, sir?
121.6.
Can anybody verify 121.6? A lot of people are raising their hands. Okay, if you didn't get that, come and see me later. And this is enough time spent on regression. And there's a lot of things in this chapter. Let's just kind of keep clipping through them. So, next. Well, if I have 2x squared plus 4x is less than 7, would you please solve that quadratic? And hint, you're going to be solving it and finding it after you subtract 7 from both sides, because you don't want to do these until it's equal to 0. And then when you're done with that, you're going to generally know that the parabola kind of looks like this. And then hopefully you'll understand what the less than even means. Now I personally like to start with a sketch. If I start with a sketch without even subtracting the 7, it'd be okay. I know there's a parabola, and this parabola, before I move the 7, would go through 0. All right? And if I can factor it, I should, right? So I take out the 2x and I'd have x plus 2. And then I go, oh, 0 and negative 2 are my two spots. This is how it would look before I move the 7. And then there's a line at 7. So I'm going to draw a line through at 7. And it's like, when is the parabola less than 7? And basically, it's in that whole zone where the parabola is less than 7. And I'd need to figure out what those two key spots were. Those are called the roots, the zeros. Now, really, when you subtract 7, the whole thing, all of it, moves down 7. If I could just grab this right here and move it down, it would kind of look like this. And then I'd have a line at 0, because now it is 2x squared plus 4x minus 7 is less than 0. And then the question really is, when is the parabola below 0, which is from there to there. So I still really need to find those spots where they cross. Now, did I make it so it could factor? Did anybody find a way to factor it? Because if you can factor it, you should. But I don't think you can in this case. So therefore, you'd have to resort to finding these roots using the what? Quadratic formula. Okay. Now that I know those two numbers, and I don't, but I'm going to ask somebody in a minute to use the quadratic formula to get them. I'll know that it's between them. How do I know it's between them? Because the parabola needs to be below or less than 0. And that's between the two numbers. So then it comes down to, what are the two numbers? I would think of two ways you could do this. One, since it can't factor, you could go put it in the calculator and graph it and see what the roots are that way. Option B, quadratic formula. I'm curious, what did you do? Did you do quadratic formula or did you graph it?
Quadratic.
Okay. What did you do? Quadratic formula or graph it? Did anybody graph it? All right. Could you have graphed it on the test? Yeah. Might that be easier?
Yeah, probably.
Okay. And then the only thing is, make sure you show your work, because if all you have is the answer, used calculator is not good enough work. You'd have to sketch for me what it looked like. And if you put exact coordinates of both points, I'll know you must have graphed it, because you wouldn't know the exact coordinates of both points unless you had done that. Okay. All right. So with quadratic formula, what did you get? Do you have the answers or not? It's okay if you don't. All right. Do you have the answers yet with the quadratic formula?
No.
Okay. Who's got them? Do you have them?
Yes.
Hit me.
I got 1.1 and negative 3.
-3.1 and 1.1. Can anybody verify those two numbers? Nobody can verify that. What did you get? Is that what you got?
Yeah, yeah.
You got those two numbers also? All right. Did you get something different, sir?
I got 2.24 and negative 6.24.
Can anybody verify that one?
I got this. I got negative 3.1 and 1.1.
solve it.
Yeah. I got the same as on the board.
Do you have the negative 3.1 and the 1.1? Is that what you got too?
I got 1.1 and negative 3.1.
If you got 1.1, you probably got negative 3.1. Okay. All right, good. So just in case there might be some confusion on the quadratic formula here, it would be x equals negative 4 plus and minus the square root of 16 minus 4 times 2 times negative 7 all over 2a, which is 2 times 2 is 4. So negative 4 plus and minus the square root of is 28, 56, there's two negatives, means 56, 66, 70. Was it 72?
Yeah.
Okay, all over 4. And it's just a matter of simplifying that down. What if they allowed you to write the answer in simplest radical form? Well, I still wouldn't be done, because the square root of 72 could break up. Know what I mean? It's probably either 4 goes in it, or 16 goes in it, or 9 might go in it. Yeah, 9 definitely goes in it. 36 goes in it, thank you. All right, so there's a lot of ways to break that up. Okay, I think we've beaten that one to death. It involved a lot of good things. When you do set it equal to 0, step 1. You look to factor, step 2. Doesn't factor, you got to know how to solve quadratics anyway. Quadratic formula or graph it. That was step 3. Then, when you're all done, you have to know that it's less than 0 is what you really want. And so it's the part between those two numbers that's the final answer. Okay, that was a lot. What else do you have to know? Slide. Absolute values were definitely a thing this chapter. So let's look at just a simple one. Absolute value of 2x minus 7 is equal to 2. Now pause for a second while you solve that basic absolute value. Okay, so shout out to Quinn. Hope you're feeling better. Breaking this up, 2x minus 7 equals 2. 2x minus 7 equals what? Negative 2. Then I'm going to add 7, 2x equals 9, divide by 2, divide by 2. X equals 9 halves, which is the same thing as 4.5. The other one, add 7, 2x equals 5. X equals 5 halves, aka 2.5. So it's 4.5 and 2.5. Raise your hand if you had those right. Awesome. Slight tweak. This is honors pre-calc. That's a question from higher algebra. So what do we do different?
Add the x to the 2.
We must say less than, or yeah, you're right. We could have made this into like a quadratic or something, but I'm just going to make it a less than. Less than or equal to. So now you're going to have to think through one more layer. If it says less than or equal to, my advice, make a little picture for yourself. And see where the absolute value is less than 2. What I mean by that? Here's my little picture. This V shape has been moved to the right and stretched. So it might be like that. And here's the line y equals 2. And the question is, where was the V shape less than the 2? It was only in this little zone right here. So it's between the two numbers. And so you should have said 2.5 to 4.5. And does it have an or equals? Yes, it does. So I use brackets. Raise your hand if you had that one right. Just can't stop you guys. All right. So, any questions about that one? Any follow-ups on that one? Yes, you could write that as a, what's that form called? Set builder, I think you'd say. Okay, next up. There was a small little part of this chapter where we talked about, here's a line, and it's got a slope. Here's a line, it's got a slope also. The blue one. But it's a curve, Mr. Server. That could have like a bajillion different slopes. Then I would say, oh, tell me the slope between 1 and 4. Do you remember this? Find the slope between 1 and 4. The point, it's not a point of 1 comma 4. It's a slope of this parabola between 1 and 4. Okay, I hope you realize you really needed a point here. 1 comma something. How do you figure out the rest of the point? 1 comma, you put the 1 in. 1 squared is 1 times 2 is 2 plus 3 is 5. 1 comma 5. Raise your hand if you had 1 comma 5. Awesome. And the other point would be 4 comma, well, put the 4 in. And 4 squared is 16 times 2 is 32, 35. Now could you find a slope? Yeah. Once you know it's 1 goes with 5 and 4 goes to 35, Then the slope isn't that hard. It's you could say f of b minus f of a over b minus a, or you could just go 35 minus 5 over 4 minus 1, which would give us 30 over 3, which would give us 10. Raise your hand if you had 10 before I did. Okay, awesome. So that was the slope. All right, now we talked about a few more slopes that were more like straight line kind of slopes. So I'm about to change the page, so if you're copying anything down, do it quick. All right. If I gave you that slope, could this, that line, sorry, could this be my equation? Could that possibly be the right equation? There's two reasons why. Give me one of the two reasons why. Yes?
Well, you have a negative slope and your line is going positive.
My line's actually got a positive slope, so that can't be right. Very good. And what else? Yes, Miss K.
The intercept is negative. And
Very good. This is indicating an intercept of y equals positive, but this one's actually got a negative y-intercept. Okay, next question that would be kind of like that would be, let's say I gave you an equation. This time I'm going to give you an equation, not a graph. What if I wanted you to tell me an equation of a line that was perpendicular to this line and goes through 1, 1? I always think it's a good idea to sketch, but you don't have to. There's more than one way to do this. But if you sketched it, you'd see it was a really steep line with a y-intercept of 4. And I need a point. It's going to go through 1, 1 and be perpendicular to this. I'll pause for a second while you give that a try. All right, so if I wanted this to be perpendicular, I know it's going to kind of look like that. So if you look at that and go, okay, needs a negative slope, that'll keep you from just going, oh, 1/6. A lot of people go, just got to do the reciprocal. No, you need the negative reciprocal. See how making the picture of it really helps? Because when I see the picture, I know that's a negative slope. Okay, so it's y equals negative 1/6 x, and then what's my b term? Well, you could do it this way. Another way to do it would be, you could go, so plus b, or you could go y minus y sub 1 equals m, which we just figured out, negative 1/6, x minus x sub 1. And then we put in a point. What is our point? 1, 1. So either 1, 1 is going to go in this equation. I like to show you a diversity of ways. Either 1, 1 could go here, and then I can find my b that way. Do you get how that was pretty quick? And I now know that my b must be positive 1/6. See what just happened there?
No.
I just took y equals mx plus b form, and I stuck in the point we needed to go through, 1, 1, and I put it in here and here. And then, oh, wait, I did make a mistake. I tried to do too much in my head. I should have multiplied both, I should have cleared my fraction, multiplied by 6. That's my problem. Okay, so I'm going to times by 6 here, and I'm going to times by 6 here. 6 cancels the 6, and this becomes a 6 equals negative 1. And I got to times this by 6 also, plus 6b. Then I'm going to add 1 to both sides and make it 7, and hopefully it's 7/6. All right, but I bet you most of you guys did it this way. So I'm going to do it that way. And I put in my point 1, 1. 1 goes here, 1 goes here. Part of the beauty is you're done. That is an equation that goes through that point with that slope. Okay, next topic we got to be ready for the test is basically the lab stuff. Okay, that stuff's on this test. And so let's talk through that stuff. And I know we have a lab, we could grade it, but try to grade homework and a lab and review all in the same day, we wouldn't have time. So I will still get to that lab. my plan will be to grade it on the day after the test. So you'll get your test back. Ideal world, you take test tomorrow and you get test back Wednesday, and we grade the lab Wednesday also. But we will see. Okay, so how do you write an equation for something that is going upward at 6 meters per second and has a starting height of 3 meters? Write an equation for that. You should be able to do that. All right, in case you forgot, it's negative 4.9. And I'm going to use x this time, just to show you can use t, you can use x, doesn't really matter. Plus 6 meters per second is 6x. And then the height 3 plus 3 meters. There it is. Now would you please sketch it, and would you agree that it's very likely that this ball will cross 10 meters? It started at 9. Well, actually, it's hard. Sorry, started at 3. I guess you can't know that it'll cross 10 meters. How about this? If it's starting at 3 meters, we know it'll cross 4 meters, right? It's going to at least go up 1 meter. This 6 meters per second thing, I feel like it would hit 9, but I guess I don't know. So let's just go to 4 meters. So here's a quick sketch. Do I know how high it went? No. Could I figure it out? Yes. Do I know how high it was when it started? Yes. How would I figure that out? Yeah, but it's the y-intercept, so you could set x equal to 0. For the y-int, you'd set x equals 0. For this spot, there's a formula for that. There's an app for that. What is it?
X equals
Negative b over 2a. And the next up is that spot, the spot where it hits the ground. Yes?
Quadratic function.
Quadratic. Very good. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 12 minutes morning. All right. I'm just trying to help you to be able to find all of these things, okay? So on the test, we can't ask you to do all of this in one question, but I'm not willing to tell you which one you have to do. All right. All right, one last thing we could ask you is, where is the ball at time equals 1? Do you know for sure? Well, not unless you, use math. Okay, so time equals 1. Let's say it's right there at time equals 1. If I put t equals 1 right there, it kind of gives you a hint what you're supposed to do. You put in 1 into the what? X. Then, the last thing we could ask you is, instead of telling you a time, we could tell you a height. Because we got this equation right, and if you put in the time, you're going to put it there and there. But what if we tell you the height? You could put it into the y, and then you could do the quadratic to solve it. But quadratics always have to set it equal to 0. So anyway, that's an option. Another option is this line going across here. If you wanted to do it graphically, remember you've got a calculator, right? So how do you type in y equals, remember me saying it would for sure go through 4 meters? Well, you type in y equals 4. Okay? All right. You guys know these with different letters than I'm about to use, so this is likely to really mess some kids up. Okay? What's a vertex now? Don't say it, write it. Don't say negative b over 2a, because there isn't an a, b, and a c in this one. There is. Now assume for a moment that I could also find the x-intercept because I could set y equal to 0, right? Would you please find the x-intercept for me, or intercepts? Would you please find the y intercept. And would you please find the vertex
Bless you.
You can look up at the board if you'd like to see whether you got the x-intercepts correct, which would be this. I know it's gross, but that's what it would be. The y-intercept, I like to put it as a point, because the y-intercept is x is 0, right? So 0 comma m. Y equals m looks like a line. You know, y equals m, which should be a line that goes across at m. But if you want it to be a y-intercept, then you really ought to write it like this. And last but not least, the vertex, x equals negative q over 2r. But wait, Mr. Server, that's not a vertex. That's the axis of symmetry. What actually would the vertex be? It would be negative q over 2r, comma, this will be gross, but you'd put that into the equation to find the y, right? Because this is where y was. Y equals that. So it would be r, and then the x is the thing that we have here, negative q over 2r squared, plus, need to make more room for myself, second here, q times negative q over 2r plus m. Whew. There, that's the vertex. You're an honest pre-calc, so we oftentimes will do stuff where the only thing that makes it really hard is we throw in a bunch of variables. It's constants, a bunch of constants. Yes?
So if you just give x on the text, that would be wrong.
Yeah, that's not the vertex. That's the x of the vertex. That would be the axis of symmetry. Okay. Next thing. The question is, when was g of x greater than f of x? Okay, so g of x is the red line. So the question is, when is the red line bigger than the black line? That's in this zone between those two from -1 to 10. And is it bigger when it's touching the other one? No, parentheses. If that had an or equal sign right here, I'd have used brackets, but it did not. There you go. Raise your hand if you had that one right. Okay, awesome. Now, I know you'd know how to do absolute value of this function. But do you remember the two different ways we could do absolute value of that function? Would you please figure out what f of the absolute value of x is for this particular parabola? It's got a vertex over here. Do you remember what that would look like? Versus, I'm going to do in green, the other one. There's two completely different looking answers. Okay, the black one is where everything on this left side needs to go and then get replaced by the other side reflecting over. It's going to roughly look like this. I'll do it in black. Kind of like a W. Raise your hand if you had that one right. Okay, awesome. Then what if I said that was less than -1? Well, then I could make a line at -1, and I could say, when was that W-looking thing less than -1? Well, here would be the two key points. And when is the black one? Less than means below the line -1. It'd be this whole zone from here to here. All right. Conversely, we could say, when is the green one, which by the way would have been, this starts going down, but then all the stuff that was below 0 gets bounced back up again. It'd look like that. Raise your hand if your green one looked like mine. Okay, good. Then what if I said, when is that less than -1? Here's the line y equals -1. When was it? When was this function less than -1? Never was. No solution. Okay. And that is enough of a review. What I would recommend that you do at home tonight is find several problems that you skipped in the past. You should go do them over again. Or find ones you did before, but it's been a week and a half and you forgot. Erase them, do them over again. All right. Have a great day.